So hello everyone again and welcome to my channel. So in here we're going to be looking at copper catalyzed oxidation. So this is kind of an interesting reaction which involves a metal catalyst by the name of copper, pretty much attached to various ligands, but this is just to be able to stabilize the energy levels of copper. Otherwise, this needs to be facilitated in the presence of air. So air is pretty much a very important reagent in this particular process, and sometimes usually include the name aerobic oxidation in this particular case. So what do you know about oxidation in organic chemistry? We know that we need to transition from alcohol to aldehyde and to carboxylic acid with the presence of various interesting reagents. Like for example, we have these two transitions going from aldehyde back to alcohol, which is a reduction process, and this requires the presence of lithium aluminum halide in the presence of TMF, and then you need sodium hydroxide to actually quench this reaction after you're finished reducing this to that. But our focus is not on this particular point here. Our focus is on this other side, which involves the transformation of the hydroxyl group into an aldehyde group. So this is our main focus over here. And what are the key players that will be involved in this particular reaction? We have acetonitrile, and we include a copper attached to a specific ligand over here in the presence of another ligand here, and then you have tempo, which is a very interesting reagent in this particular reaction overall, and finally we add N-methyl imidazole. So let's look at a little history behind the formation of this particular product over here in the presence of copper. First, a particular scientist by the name of Gaasbeck, what he understood was that an alcohol oxidation in the presence of atmospheric oxygen requires the presence of a copper salt, and this copper salt needs to be coupled with a nitroxyl radical. And once this is required, we need to notice that his combination in this process was due to the presence of a phenhydroline, which is actually the combination of copper 2 and ditritetrabutyl nitroxyl. And this particular reagent over here is actually a co-catalyst for the activation of this particular copper 2 over here. So this process was done enough for we to actually oxidize a methanol group. So that was quite interesting coming from Gaasbeck. On the other side, we have a particular scientist by the name of Semmelback. And what Semmelback did was that he used a particular copper salt called copper chloride and reacted it in the presence of 2,2,6 tetramethyl pyridine N-oxyl. And it's quite interesting because this particular reagent, as you know, is quite familiar to a short name called tempo, and tempo was done in the presence of DMF, which is a particular solvent, and DMF is also known as dimethyl formaldehyde overall. So the structure of this is actually nitrogen attached to this symmetrical side group over here, and then attached over here to an hydroxyl group over there. So it's quite fascinating that he was able to include that, and then a particular target reaction which he did this on was this particular reaction over here. So this side here being any position where this methyl group is being attached to, and then you have an hydroxyl group over here. And what he did was that he used 10 mole percent of copper chloride and then 10 mole percent as well of tempo. So it means that for every 1 mole of this particular metal catalyst, you include this particular activating group over here for this process to actually occur. And what that led was to the formation of an aldehyde functional group over here, which is a product overall. So it's quite fascinating that he did that. And next scientist that followed was Sheldon, and what Sheldon did was that he developed another ligand that will be attached to this metal group overall, and the metal group, which is still copper. What he used was to use bipyrimidine over here. Bipyrimidine is a ligand that's attached to copper. However, he included the presence of a particular halogen called boron. So in here, boron was introduced in this particular process in the presence of tempo, which is a quite addition to what we had previously over here. And then this tempo is also used as a co-catalyst in this particular reaction. Also, he included the presence of a very strong base by the name of potassium tetbutyl oxide. So it's quite impressive that he was able to include this particular reagent, which is quite a strong base, and that was how he developed this particular copper catalytic oxidation. Now finally, and the one we're going to be focusing on, and the mechanism for this particular guy is by the name of Kumpulainen. And what Kumpulainen did was that he actually replicated this process, but in this part he actually changed boron in here. So in here he used bipyrimidine as a ligand over here in the presence of copper. However, he used OTF in this particular process, and OTF is actually using 2 of those, makes it inactivating, but by activating it you'll be able to actually facilitate the oxidation process of our target functional group in the presence of oxygen.